We are in Unit 4. We are now on Lesson 3, Functions. Right, if we take a look at our standards, we are on 8F1 still. Understand that a function is a rule that assigns each input exactly one output. Now our essential question in this lesson is how can we model relationships between quantities? Okay, in order to do that, we are going to, let me forward through here. We're going to find the value of a function for a certain number. And we are also going to make function tables of values. Now in this lesson, we are going to be looking more at real-life situations, looking at equations, and creating tables from that. Up until this point, we've just had tables with basic numbers. Now we're going to be looking at actual situations. Okay, before we start, let's do a little vocabulary. Right up top here is our definition of function. If you do not already have this in your vocabulary page, make sure you add this in if you don't have it already. Okay, so just a reminder, a function is a relation in which every member of the domain is paired with exactly one member of the range. Okay, in other words, our domains are all unique. The new information here that I want you to take a look at, so this piece is our new piece. I'm going to give you a situation. Read along with me. An example of a function is m equals 20n, where m represents the amount of money earned, and n represents the number of lawns mowed. In this example, n is the independent variable, and m is the dependent variable. So they're telling you what is independent and what is dependent. Okay. Now the questions here, it says independent variable, what I think it means. Dependent variable, what I think it means. So here's what I need you to do. I want you to, you haven't heard independent or dependent variables before. However, you should know what the word independent and dependent mean just in general, in life. Think about what those numbers mean. Okay, what does it mean if somebody's independent, or what does it mean if somebody is dependent? And apply what you already know about those words to this situation. Okay, we are telling you n is an independent variable. Why would that possibly be? In general, what could an independent variable mean? And then do the same with dependent. You can go ahead and pause and fill that in. So you wrote down what you thought each of those words meant. What I need you to do now is on your vocabulary page, I want you to copy down these two definitions. First is independent variable, and second is dependent. So this will give you a little more information about each. So our independent variables are related to the input value. The input value determines the output value, so it is independent. So because this variable determines what happens, it's independent. It doesn't need any other numbers. It's the one that determines, it's like the final answer is your independent variable. Your dependent variables are related to the output value. So the output needs the input to determine the final value. Okay, so if we were to look back at our situation here, and I'll show that other screen in a second. N is independent. Okay, so N is the number of lawns mowed. So if I mow 10 lawns and you mow 10 lawns, that's the independent variable. 10 lawns got mowed no matter what. Now the reason that M would be dependent is because M depends on how much you charged per lawn. So I could mow 10 lawns and my friend could mow 10 lawns. That's not going to change. The difference comes in when I'm charging $20 per lawn and you're charging $10 per lawn. our total is going to be different. And so that total depends on the other numbers in our function. Okay, so because the dependent variable depends on everything else that's happening, that's the dependent variable. Okay, so let's bring this back up. So again, the independent variable is going to happen no matter what. Like that's 10 lawns is the lawns. Like lawns are going to happen. The price, the total money you make depends on how many lawns, how much you're making. There's all this information that it depends on. Okay, so let's take a look at a couple examples. So our first equation is C equals 0.99n. C represents the total cost, N are the music downloads. Okay, so you'll have to kind of come up with a way of how you tend to look at these and how you tend to figure it out. One way that you can kind of count on is that your dependent variable is usually going to be the final total. Okay, so the variable that represents the final total. Okay, the reason that happens is because the final total is dependent upon an operation happening. So in this case of our downloads, the total cost depends on the price per download and the number of downloads. So because I have a couple things that could possibly happen, that could possibly change, I'm depending on that information to come up with my answer. Okay, so if we look at our next equation, D equals 4.5 hours. So number of miles is D, and H is hours. Okay, so D is my total number of miles. My total number of miles depends on how fast I'm running, how far, how much time I've been running, how far I'm running. All these different things are dependent. So miles, okay, miles is my dependent value. Hours is independent. Okay, if I run for 3 hours, 3 hours is going to happen, period. Thing is, distance per hour, how fast am I running, how slow am I running, those things all change. So hours is my independent variable. The hours are going to happen, what's going to happen. Miles is dependent because it depends on how fast I'm running, how long I'm running. There are all these things that have to come into play for me to figure out the miles. Okay. All right, next one, equation. S equals G plus 3. This is the final score of the game, which is S. Oops. So final score is S, and G goals. Okay. Final score is S, and the final score depends on a lot of things to happen. The final score depends on how many goals, how many extra points, all these different things that come into play with the score. Okay. So my score is dependent. Goals is my independent variable. You're going to score how many goals you're going to score. But there's other things that you're going to get as many goals as you're going to get. But the score, there may be other factors that come in when you're looking at the score. So that's why the score is dependent, goals are independent. Okay, don't worry about this section down below. All right, we're going to take a side step from the dependent and independent and take a look at some functions. To find the value of a function for a certain number, substitute the number for the variable. Okay, what is important for you to see is this section here, this F with the X in parentheses. The way this is pronounced is F of X, function of X. Okay. What I want you to make note of, somewhere and now there are some other things you're going to be writing on the side, so you could put this in your sidebar, but you don't want to write too big. Okay, so this is read F of x. So that's in words how you say this symbol here. You don't say f parentheses x. It's f of x. F of x is actually the same thing as y. Just so you know, they're interchangeable. F of x and y are the same exact thing. And that'll make more sense in a little bit. Okay. So we'll notice in this blue box it says f is read, the function of x, or f of x. It is the output or the range. Now we also know the output and the range as the y value. Okay, so f of x and y are the same thing. It's just two different ways of saying output or y or range. And you'll see in our first example, why people say, what's the point? Why don't you just say y then? But you'll see down below in example 1. So if we take a look at example 1, it says find f of negative 3 if f of x equals 2x plus 1. So again, the way you would read that is find f of negative 3 if f of x equals 2x plus 1. Okay, so something I want you to notice. Do you see how this negative 3 is being replaced by the x? So what this is telling you is this is telling you to substitute x with negative 3. So again, it's telling you to substitute the x with a negative 3. And if you notice, right here on the second step, that's exactly what happened. I substituted the x with a negative 3, and then I just simplified the expression. And when I simplify the expression, if you focus on the right-hand side, it simplifies down to negative 5. Okay, so again, all that happened here is we substituted negative 3 for x, and then we ended up with 2 times negative 3, which was negative 6, plus 1, which becomes negative 5. Okay, I want you to take a second, and I want you to try A and B on this page. So pause and see how you did. If you need area to show your work, you can do it underneath A and B, and if there's no room underneath A and B for you to do that, you do it in your notebook. Okay, so take a look at the work for A and for B. I already substituted in the numbers for you. The 2 for A is f of 2, and B was f of 11. So check your work compared to mine and see how you did. Okay, so I would like you to find some room on the sidebar or somewhere in this area of the top half of this page. And I want you to take a look at the statement here and finish it in your own words. When given f of x and the x is a number, you blank. So if you're given, instead of f of x, it says f of 2, what do you need to do at that point? So take a look and see, what did we do in A? What did we do in B? What did you do with that number that replaced the x in the f of x? Okay, so in A, f of x became f of 2. What did you do with that 2? In B, f of x became f of 11. What happened to that 11? What did you do with that 11 to determine the final answer? Okay, hit pause and get that done. Okay, so you just saw a video on some information about function tables. There is a new piece of vocabulary here that I want you to see. It says you can organize the input, rule, and output into a function table. So add function table to your vocabulary page. Now there's a little more information here about the independent variable and the dependent variable that might be helpful for you to add. For the independent variable, it's independent because it can be any number. The dependent variable depends on the domain. It's basically what I'd said before, but this may be a wording that is helpful to you. So if you want to go add anything to your independent and dependent variable vocabulary, you might want to add that. So our independent variable can be anything. The dependent variable, that's usually our answer, whatever it equals, is usually the range. Okay, so That's another important piece of information. So the range is the dependent variable. Domain is the independent. So those are two little tips for you. Let me erase all my markings. So take a second, pause, and get your vocabulary filled out. All right, so now let's take a look at our example. Okay, example number 2. Choose 4 values for x to make a function table for f of x equals x plus 5. Then state the domain and range of the function. Okay, so here's what happened in our table. In our table, we took our formula f of x equals x plus 5. It's like we're making a function machine. If I plug in an x, I use the rule, and then a y outputs, or a range, or an f of x. Okay, so let's take a look at our first domain. Our first domain was a -2. So instead of the x, I replaced it with a -2. -2 plus 5 equals 3. So I input a -2, run it through the formula, and I output a 3. Okay? So all that's happening is I'm taking the domain values, plugging them into the formula or into the equation, and I'm getting out the range. So plugging in an x, getting a y. Okay? When you're asked to write the domain, the way it's usually written is with a little kind of a squiggly bracket, and then you list your numbers. So -2, -1, 0, 1. My range is 3, 4, 5, 6. A note about the domain and the range. It's very important when you are writing the domain and range separately in a list that the first numbers are coordinates, second numbers are coordinates, third numbers are coordinates, and the fourth numbers. If you notice, 3 and -2 are paired together. -1 and 4 are paired together. Okay, so the order is very important. You make an assumption that when you get these lists, that the first number in the domain and the first number in the range are an XY coordinate. The second number in the domain and the second number in the range are coordinates. Okay, so be very, very conscious of the order that you're writing your domain and range in.
Functions. Dina and Peter can buy DVDs for $15 each. They can make a function table to represent this situation. They start the table with a column to list the number of DVDs that are purchased. These will be the input values. They add a second column to list the total cost. These will be the output values. The total cost of one DVD is 15 times 1, or $15. The total cost of 2 DVDs is 15 times 2, or $30. The total cost of 3 DVDs is 15 times 3, or $45. The total cost of 4 DVDs is 15 times 4, or $60. The total cost of 5 DVDs is 15 times 5, or $75. We can see from the table that the total cost depends on, or is a function of, the number of DVDs purchased. A relationship that assigns exactly one output value for each input value is called a function. Functions are often written as equations. The input x is any real number. F parentheses x is read the function of x, or more simply, f of x. It is the output. In this case, we say f of x is equal to 15x.
Okay, so let's try C, see if you got it. It says choose 4 values for x to complete the function table for the function f of x equals x minus 7. Then state the domain and the range. Now, something that's very important when you are choosing your x's, you want to choose them carefully. Usually, I would pick low numbers 0, 1, -1, just because for arithmetic purposes, things tend to come out a little bit more reliable. The thing is, though, when you're thinking strategically, you want to take a look at your equation. My equation is x minus 7. So I know that whatever x is, I'm going to be subtracting 7 from it. So if you're a little bit nervous about positives and negatives, you're going to want to pick a large number, because a large number minus 7 will end up being positive. So for example, maybe you want to pick 10, because 10 minus 7 is something easy to figure out, and that's 3. That works. You could have started at 7. You could do 7, 8, 9, 10. You could have done 0, 1, 2, 3. You could do whatever you want. I would be strategic and say if I choose larger numbers, larger than 7, I'll end up with a positive f of x value. Okay, and then if I go 12, 12 minus 7 is 5. And what you notice is if you have a pattern in your x's, you should find a pattern in your y's. My x's are increasing by 1. My y's are also increasing by 1. The difference between my x and my y is 7, and that's because I'm subtracting 7. So I could assume that if I went from x from 12 to 13, my f of x would go from 5 to 6. Let's check it. And it does. Okay, our next example we are not going to do not cross it off on your paper, okay, because eventually we will come back to it. It will be revisited, but for right now, you can go ahead and skip it. Okay, we are also going to skip this section. If you would like to try it, read through it, and attempt, you can skip that last screen. If you would like to attempt the got it section, awesome, show me, I'll give you a little bit of extra credit. If you could explain to me everything on a notebook check day. All right, so let's revisit our vocabulary. If you need to back up through the video and find these words and make sure they're in your vocabulary list, please do that. Okay, for your guided practice, what we're going to do is look at number 1, find f of 4 if f of x equals x minus 6. So if you want to pause and try these on your own and then come back and see how you did, you can, or you can work along with me. So this is very similar to example 1. My x is going to become a 4. My f of x is 4. So x becomes 4. Oops, that's a 4. So f of 4 equals 4 minus 6. Add the opposite, and f of 4 equals negative 2. Number 2, choose 4 values for x to make a function table for f of x equals 8 minus x. So again, you want to think strategically. Know that you are going to be taking 8 and subtracting your x value. So I would definitely go low, and I'd go positive. If you chose a negative, you're subtracting a negative, and depending on how adventurous you feel, it might be a little bit tricky. So 8 minus 0 is 8. 8 minus 1 is 7. 8 minus 2 is 6. 8 minus 3 is 5. Make sure that you can see that 5. Okay, then state the domain and the range. So you're going to list your domains. Mine would be 0, 1, 2, 3. My range is 8, 7, 6, 5. I don't know if I talked about the pattern, if I said it correctly or not, but as my x's increased by 1, my f of x actually decreased by 1. Okay, now number 3 was like the peanut butter question. Okay, so you may skip 3. If you'd like to try it, just to see how you do, at the end I'll go back and I'll pop all that up. Number 4. How does the domain affect the range? So I want you to go back and look at your examples, look at how the domains affect the range, okay, and come up with some sort of, in your own words, how does the domain affect the range? Okay, so if you paused number 3, I answered number 3 here. So when we look at our hot air balloon, it holds 90,000 cubic feet of air. It's being inflated at a rate of 6,000 cubic feet per minute. The total cubic feet of air, which is AT, is a function of the time. So our air is going to be the dependent variable, the total cubic feet of air, because that's our total, that's our domain, It's our dependent variable. Okay, time is our range. Okay, that's the number that's going to change. That's our independent variable. That can be anything. Okay, so B says, what values make sense? So if we're looking at it holding 900 or 90,000 cubic feet, okay, I need to make sure that this number is anywhere between 0 and 90,000. And then C, the function is going to be 6,000 t, because it goes at a rate of 6,000 cubic feet per minute. And if we have 6 minutes, you end up with 36,000 feet cubed. So if you wanted to try it out, and that makes sense, great. We will return back to this type of problem, so don't stress if number 3 makes no sense to you. Okay, now you're ready for the self-check. You have the QR code up here. When you get to the self-check, any problems like number 3 on the guided practice are not required. Okay, so any of the word problems like number 3 are not required. The only problems you need to work on are the ones with the function table or f of x with the equation. Those need to be in your notebook. Okay, and then it's your turn. So check the next Schoology post for which problems on the independent and extra practice you're required. This little QR code will pull up a file with a few of the problems done for you. That's it.